Good afternoon, ladies and gentlemen. Goeiemiddag, dames en here. Dumelang bome libontate. Baie welkom. Ons is by dag 6 van ons aanlyn ingenieursweek. And with today, day 6 of our online engineering week, we will be focusing on electronic engineering. And that's quite exciting because in the past, we usually had one session to cover electronic, computer electronic, electromechanical, and then also from this year, mechatronic. That used to be part of one session. But now, because there are always so many questions with regards to what is the difference between this engineering field and this engineering field, and because we have time, we are going to focus on each one of these disciplines, one discipline at a time. So vanmiddag fokus ons spesifiek op elektries-elektroniese ingenieurswese. Ek wil julle weer eens uitnooi, as daar enige vrae is, moenie huiwer om die vrae te tik vir ons daarso in die chat funksie van YouTube nie. If there are any questions, please feel free to send those questions. We will be answering them live right here on YouTube. Right, so today it's wonderful, and that's what technology has made possible. Our guest will be talking to us all the way from Austria, Oostenrijk, nie Australië nie, Austria, different place. Dr. Albert Sorgdrager, en ek wil net kortliks 'n CV hierso voorhou. He finished his B.Eng in 2010 and his Masters in Engineering in 2013 at the Northwest University. Then he continued with his PhD at the University of Stellenbosch in 2017, and then he started his career at Sasol Group Technology. And he's currently an engineer at Magna Powertrain Engineering Center in Steyr, Austria, and he's talking to us live from Linz. If you want to know where Linz is, it's halfway between Vienna and Salzburg. It's in the middle in Austria, and he is part of this company, a supplier of automotive parts and systems to most of the world's original equipment manufacturers. And he's part of the group that works on development, construction, and testing of electrical machines for electrical drive systems. And this includes serial design concepts, as well as next generation technology development and demo vehicle system development. Grüezi, or servus should I say. Welcome, Albert.
I'm Corneels. In Austria, we say Grüß Gott or Grüß dich.
Oh, Grüß Gott.
That's a bit different. That's all the dialects of German. Each has his own. So no, thank you for the introduction. Like you said, currently I work in the automotive industry, but my origin was in the petrochemical industry in South Africa, which was Sasol, or is Sasol. It still is. They were also the reason for my studies. They supported me from my first year. So for the first 4 years, I had a Sasol bursary. And then, let's say, to the end of my 4th year, I decided that this study thing, it's still nice. I don't want to go and work yet. And at that time, Sasol had this vision to develop non-critical specialists. So that's people that's not chemists and not chemical engineers. And then I had the opportunity to do a master's. And luckily at that time, it was electrical machines was a quite established topic in terms of industry research. And I thought, let's give it a go. And I applied for the bursary for my master's, and luckily I got the scholarship to study for the master's. And after about a year and a half, I thought to myself, I'm still not ready to go and work. Let's push it for a PhD. And I was in the race, and then I applied for the PhD bursary, and I just continued on in the same field, but at a different university. Luckily, let's call it my supervision team, which was Professor Grobler, who's at Northwest University, and then Professor Wang, who's at Stellenbosch, basically just reversed roles, and we continued on the same topic. And that's, let's say, my study field. And then I started in Sasol, and I worked in group technology. And At Sasol, they've got what they call a graduate development program. So regardless of what industry or what field you study, you go through this graduate development program. And it's 3 years, which is structured, and you get exposure in your specific discipline. And there I learned a lot of things in terms of general electrical engineering. So me, with my PhD, still had to go through that graduate development program. And it was at that time quite a, the joke in the plant was that the guys that I used to give class for at the Northwest University is now the guys that's teaching me how to do the stuff on the plant, because most of the engineers were younger than me at that time. But I still had to go through the paces. So just because I had the PhD didn't mean I was fast-tracked in terms of growing. I still had to learn the trades of the industry. The benefit was, because of my qualification, I could progress a lot faster than my peers. And after 18 months, I was finished with the GDP program. And at that time, I had the option to start working as a full engineer. And around about that time, I also got the request for an interview in this automotive company, which I've never heard of. And most of us know that in South Africa, automotive is not really a big industry. We don't even really learn about it in the undergrad, or even it's not a known thing. We do industry, we do mines, we do petrochemical, we do power generation, all the typical traditional electrical engineering stuff. And then I said, well, I did the interview, and I thought to myself, this is like in my yard house. I'm going to design electrical motors for vehicles. And then I thought to myself, but Magna, they don't manufacture cars, so what's the company? So basically, Magna is what they call a tier 1 parts and system supplier. So you think you buy a Volkswagen or a BMW or Mercedes, and all the parts in that car is originally from OEM, but it's not. OEM is basically the guys that take all these parts together and make the vehicle. So they go out and say, we request this component, we need that, and they get tier 1s to supply them that. And the benefit of tier 1 suppliers is they reduce the price, because we distribute the same components in more than one OEM. Benefit is, for me, is luckily then I get exposure to all different car brands, all different car requirements. Currently, I'm working on a main drive traction project, so similar to like you find in a Tesla. But also, I've got some other projects that's hybrid drive applications, like a Prius or the typical German cars that come out with the plug-in hybrids these days. So I went from this petrochemical, massive megawatt machines to now kilowatt high-speed machines, and I could still, because of my background, do both.
Baie dankie, Albert. So dis weer eens vir die van julle wat vir die eerste keer met ons is en luister, sal sien ons kry 'n bepaalde patroon wat ons optel nou al, soos ons met die verskillende persone praat wat in die industrie is. Die eerste ding wat ek weet baie ouers oor vra is die graad wat jy verwerf by die NWU internasionaal erkend? En ons het vandag uit die aard vir die saak vir Dr. Albert Sorgdrager wat met ons praat al die pad uit Lens, Oostenryk. Ons het laasweek ons by Jan Pieterse gehad wat al die pad uit Duitsland uit met ons gesels het. So daai vraag dink ek is voldoende al beantwoord, maar as ons moet aangaan sal ons nog van ons alumni kry wat oor see werk. So dit is moontlik om oor see te werk. Die ander ding wat ek optel uit dit wat jy sê, Albert, is dat die veld waarin jy is nie noodwendig die veld waarin ons dink die tipe ingenieur sal werk wat jy studeer het nie, maar dis ook 'n patroon wat ons tot dusver kry. Mense swat in 'n sekere lyn en hulle eindig in iets heeltemal anders. So I'm going to ask a general question, a broad question. So there are people looking at watching live what's going on, and the question is, what exactly is a electronic engineer, and typically where do they work? Within the South African context, but also in the international context. Where do people with a degree like yours typically work?
I think in South Africa, it's very obvious. You've got your big suppliers like Eskom, Transnet, which is the railroad, or Praza. Then you've got all the mines where you can work. Sometimes you combine it with mechanical, and then you get your government ticket at the end of the day. Then you've got your petrochemical, like I said in the past, where I worked in Sasol. Then there's also other places that's also known, but maybe not that obvious. You've got typical places like Denel, the military munitions manufacturers. And there's assembly plants where you can also work. So in PE, where we've got the automotive production places. For me personally, the opportunities is endless in terms of where you can work as a electrical engineer in South Africa. You can also find yourself in financial sector, so banking, insurance houses, because you learn a lot about modeling, optimization, system development. So whether it's the insurance system and how to optimize and function that, or whether it's our grid regulator at Eskom, the concepts stay the same. And that's why you can find yourself as an electronical engineer in most of these areas. I think at the end of the day, the limit of where you can work within South Africa with your electronic engineering degree is only set by yourself. I also sometimes tell people your undergrad degree doesn't define you as an engineer. It gives you this tool set to be able to work in environments. It differentiates you from your chemical engineering degree colleagues, because it's still an engineering degree, but they've got a different approach. It also differentiates you between your peer BSc people, where they've got more meticulous approaches and we've got a more systematic approach. And then at the end of the day, outside of South Africa, there's endless possibilities. I think what I've found personally is that engineering in South Africa is very much industry driven. So you go and work for the industry, and there's some engineering research facilities like the NEL or the CSRI. You can do that traditional concept of research and development, where when you go to outside into Europe, that's where you'll find more research and development, component manufacturing, design. Even though the manufacturing doesn't happen in Europe that often anymore, the engineering happens here, the design, the validation, that concepts happen there as well. Then I think another aspect that also comes into role is engineering consulting houses. I know Oricon's name has most probably been dropped over the last couple of weeks or days in some of the interviews. You also get companies like Fluor or BHP Billiton, where you basically move from project to project. So this project, you are situated somewhere in the Middle East, and then in 2 years' time, you can find yourself somewhere in the middle of Africa or Australia or you name it. So I think at the end of the day, your degree, you've summed it up a couple of times very good, is your South African engineering degree gives you the capability to work in the industry that you want, in the country that you want, and also the language that you want, if I can put it like that, because that's also a big factor that you need to realize. Once you move out of South Africa, English is not always the norm, and you need to learn then a new language most probably, and it's frustrating, but it's at the end of the day, it comes with its benefit as well.
Baie dankie Albert, en ek kan aanneem, daar waar jy in 'n Oostenrykse samelewing is, gaan jy nie net met Duits leer nie, jy gaan Duits met 'n dialek moet leer, want hulle praat maar 'n interessante Duits daarso. Maar ek wil daai punt net herhaal, want ek dink dis iets wat mense moet hoor. Wat is die waarde van 'n ingenieursgraad? Jy het gehoor wat het Dr. Albert Sorgdraer gesê. Dit stel jou in staat om te gaan werk in die industrie van jou keuse, in die land van jou keuse, in die taal nie noodwendig van jou keuse nie, maar die taal van wat daar gepraat word. Maar die punt is, dit is 'n graad wat jou in staat stel om jou drome te kan najaag, en die opsies is legio. En ons kry dit uit al die monde van al die alumni wat tot dusver gepraat het, die plekke waar hulle werk, wat mense tree wil terugvat en sê, maar dit klink nie heeltemal asof hierdie persoon in dieselfde lyn is presies as wat die persoon studeer het nie, maar die persoon is in daai lyn, floreer en dit gaan goed. Nou ek wil volgende paneellid aan die woord stel en dit is professor Andrei Grobler. Now he is a lecturer within the School of Computer Electronic Engineering and he is an electrical electronic engineer. So good afternoon, Andrei. My question to you, I want to get to the nitty-gritty. So we've talked a bit conceptually about this degree, but I want to know, to be more specific, what part of industry, let's say Sasol will employ a couple of different engineers. What exactly, and perhaps I'm making it too narrow, but what exactly will an electronic engineer do at a plant like Sasol, at Eskom? What part of the bigger business will they be specialists in? If you could just help the listeners out there to understand, where do electronic engineers, where do they fit into the bigger picture?
Hi, Corneels. Yes, thanks for the question. So electrical engineers are concerned with getting the electricity to the things that need it. In a plant like Sasol, it would be you've got a specific fluid that you need to get from one place to another. So you've got a pump. The electrical engineer will be concerned with getting the electrical power to that pump to be able to get the fluid to where it needs to be. Also supplying all of the other things. There's a lot of things on a plant, or even in a mall or in a house or in a shopping center, which requires electricity at various levels and various amounts. So your air conditioning system in a mall, or the ventilation system in a mall, the lighting and the alarms and all of those things require electricity. So in those, and the guys working in consulting will a lot of the times be advising or doing those designs when a new mall is built, or when a new house is built, or when a new plant is built. Those guys will be involved. Also, if you're looking at the larger scale, at Eskom scale, you'll have places where you generate. Um, at the moment, we're seeing a lot of renewable energy being established. So, and it's even in Northwest, we've got I know close to here, there's quite a large PV plant being established. So the connection of that plant to the grid, and then getting the electricity from where it's generated to where it's needed. That's another important one. In municipalities, we'll also have a lot of electrical engineers um, also doing this, making sure that the electrical supply remains stable, and the equipment that's required there keeps on working and is maintained and is kept working as it should. Um, that's the electrical side. In the electronic side, we're going to the smaller things, smaller currents, kind of levels where you, say, for instance, have a tracking system, or you've got a telecommunication system that also requires electricity, but needs it at another level, at a 12-volt DC, or a much smaller, thinner wires. But also in those circumstances, you also have some challenges. You want to use as cheap a cable as possible, for instance, or you want to um, need very reliable supply. If you're thinking of a data center where you've got all of us are talking, and all of the information, there's a lot of electrical supply and a lot of electronics from where my camera is picking up this signal, this optical signal, to where you're sitting, to where Albert is sitting, and it's really quite impressive to think that all of these zeros and ones are getting to everywhere, to all of these. And there's a lot of electronical devices, the power supply in this laptop of mine, the buttons and all of those things are electronic components. Your cell phone is a collection of a bunch of electronic components and telecommunication and software, which is the computer electronic side of things.
Andre, if I can ask you, if you look at the curriculum, So we have these 4 programs, and that's always the question. What is the difference between electric, electronic, computer electronic, mechatronic, electromechanical? We're focusing on electric, electronic now. Which subjects will be the niche subjects within this curriculum that is unique to this program?
Okay, the first 3 semesters is exactly the same. So just to start off with that, you shouldn't be very anxious that you make the right choice. Make the right choice to come to the Northwest University, but don't fret too much about electrical, electronic, mechatronic. The first 3 semesters gives you some time to sort that out. Obviously, if you know already, then that's fine. But the subjects are the same for the first 3 semesters. From there, we'll have the same electronics subjects as computer electronic engineering, but then we'll add power electronics. Power electronics is the really high voltage and current levels, things you get in these megawatt converters for your the cars that Albert is working on, their electronics will be very specific. So that's power electronics, which is one of the niche subjects. Then also we've got power systems, which is these transportation highways of electrical power. If you drive anywhere, you'll see big transmission cables. Those are all power systems. There's also power system protection, which is quite important. So you've got this megawatt machine. How do you protect it? How do you stop it from blowing up or being damaged? Transformers being protected. That's also a subset of power systems. And then we also have electrical machines, which is more towards what Albert is designing in his daily life. But electric machines are transformers, electric motors, electric generators, those kind of things. That is also a niche part of electrical engineering. We also share the subjects control theory with computer electronic engineering. And then we also have an introduction into programming and telecommunication systems together with the other ones. But those, the power electronics, the power systems, and then electric machines are the niche areas in electrical engineering.
Baie dankie Andre. En ek dink wat jy vir ons sê, en dis goeie nuus. Dis goeie nuus vir ons kykers. As jy met ander woorde sit en jy sê, "Wel, ek kan nie 'n besluit maak nie. Ek weet nie of moet ek elektries elektronies, rekenaar elektronies, megatronies, elektromeganies doen nie." Die goeie nuus wat Prof Andre Grobler vanmiddag met ons deel is dat die eerste 3 semesters, met ander woorde, jou hele eerste jaar en dan die eerste 6 maande, die eerste helfte van jou tweede jaar is dieselfde. Met ander woorde, jy het nog so 18 maande grasie om finaal daardie besluit te neem. And 18 months is a long time. It's a year and a half. That gives you enough time to shadow people actually working in industry, doing your own research and making sure whether this is the field that you want to choose. And that's wonderful. So there are some subjects, just as a side note, that are general for all engineering disciplines. I'm thinking about things like physics. I'm thinking like subjects like mathematics, applied mathematics. Those are common to all 8 engineering programs. But then there are specific subjects only related to certain programs, like power systems, if I recall correctly. And then there are sometimes some subjects that overlap between certain programs, like process control or the like, that you have that. So if you can just distinguish between that, then that will be good for you to do that. Right, so a question from the field. Franco Nel vra 'n vraag. Franco, ons gaan jou vraag hanteer. Ek gaan hom eers in Afrikaans vra en dan in Engels. En ek gaan dit sommer vir jou gooi, Andre, en daarna vir Albert vir jou ook, want jy sit lekker in die industrie. Die vraag is: waar word wiskunde gebruik in hierdie veld? Where do we use mathematics in this field of study? First Andre, and then moving over to Albert all the way in Linz.
Okay, dankie. Wel, ek kan onthou ek wiskunde by die konsultasie maatskappy waar ek gewerk het gebruik het, was om laste bymekaar te tel. Dit klink nou eenvoudig, maar jy het 5 aircons en 3 pompe en al hierdie laste moet bymekaar getel word. Nou gewoonlik gebruik ons sagteware programme om jou te help, maar die basis of die gut feel, die gevoel wat jy het vir, is hierdie megawatte, is dit kilowatte, wat is die limite waarna ons behoort te wees? Dis iets wat jy uit jou eie wiskunde ervaring uit sal hê. Daar is iets soos integrasie is wanneer jy is iets wat jy veral sal teekom in die hernubare bedryf. So jy sit jou sonpanele op, maar watter gradiënt fokus jy hulle? Hoe pak jy hulle? En daai hang af van hoe die son beweeg deur die loop van die jaar en afhangend van wat is die voorsiening wat jy wil lewer. So as jy die meeste energie wil uitkry, dan sal 'n sekere gradiënt wat jy wil regkry, maar as jy in die wintermaande net soveel as die somermaande wil hê, dan gaan jy dalk 'n ander gradiënt kry. So integrasie sou 'n voorbeeld wees waar jy al hierdie daaglikse of uurlikse energie, opgewekte energie van jou sonpanele kan bymekaar tel en dan deur die jaar kan sê, okay, ons gaan vir maksimum wins of maksimum produksie, of ons gaan vir 'n sekere piek in 'n sekere wintermaand byvoorbeeld. Dis so vinnig 2 wiskundes waarna ek kan dink, dalk kan Albert vir ons ook 'n paar gee.
Ag, ek kan daarby byvoeg, Andre. Ek dink een ding wat ek ook wil by sê is dat jou wiskunde wat jy gaan gebruik is ook afhanklik van die area waarin jy werk. So ek het by Sasol 'n baie meer eenvoudiger wiskunde gebruik. Want dit was 'n kragstelsel wat redelik al bestaan en goed is uitgewerk. Dit is spanningvlakke soos bymekaar tel, drywingshoeke uitwerk met baie meer eenvoudige wiskunde, voordat die stelsel so goed ontwerp was. Dan, as ek nou dink aan my daaglikse werk nou in die automotive, maar veral in die ontwerp, gebruik ek glo dit of nie baie meer programmering as wat ek ooit gedink het ek sou gebruik het in elektriese ingenieurs. So dis ook 'n wanpersepsie wat baie mense het om te dink dat oor ek 'n elektriese ingenieur is, gaan ek nie programmeer nie. Jy gaan programmeer. As jy 'n ingenieur is, gaan jy programmeer. En by default gaan jy dan wiskunde gebruik. So in my daaglikse gebruik nou, is wiskunde actually vir my baie belangrik in die terme van, soos Andre gesê het, weet jou integrasie van harmonieke wat ontwikkel word in jou stelsel van hoe ek ontwerp. Dan ding wat ons nou baie gebruik is geometrie van hoe die motor aan die binnekant lyk. Weet, daai is 'n wiskundige funksies. So jou meetkundige goed wat jy op skool gebruik, is dit nou net 'n volgende vlak, maar meeste topologieë van elektriese motors word blootgestel deur wiskundige funksies. En dis geprogrammeer en dis optimering op die einde van die dag. 'n Ding wat ek ook baie gebruik. En optimering is niks anders as 'n wiskundige algoritme wat net deur 'n rekenaar oor en oor getoets word. So, dis soos ek sê, daar's verskillende wiskundige behoeftes vir verskillende areas. So, soos ek sê, in jou meer established areas is jou wiskundige gebruik baie meer eenvoudig. As jy na nuwe areas toe beweeg, dan begin dit bietjie meer gekompliseerd raak. Ek dink in elektronika as die wiskunde is ook baie meer matrix gebaseerd, waar jy weet hierdie talle matrikse het wat opgeroep word. En veral in proteksie is ook, die proteksiesisteme is alles word deur matrikse op die einde van die dag blootgestel. So nee, jy gaan definitief wiskunde gebruik. Ek dink nie jy gaan dit gebruik so erg soos wat jy geleer het op universiteit nie, maar jy gaan nie wegkom van daar af nie. Maar die feit dat ek dink dis 'n voordeel wat ons het in Suid-Afrika is ons wiskundige blootstelling op universiteit is baie hoog. En daarom is ons nie bang om weg te beweeg van 'n bietjie meer komplekse probleem waar jy bietjie meer komplekse wiskunde nodig het nie. Want jy het die blootstelling, jy weet waar om te gaan kyk en jy weet hoe om dit te implementeer. Ja, jy gaan wiskunde gebruik, net verskillende wiskundes op die einde van die dag.
So there you have it. Yes, you are going to use maths. And this sounds like a question that's many times asked at school level. Why do I have to do this module? I will never do this one day in my career. And then you get to university and you see something similar. But the long and the short is it depends on where you end. And in my days when I worked at Sasol, sometimes the most complex work that I had to do with regards to calculations, I did using Excel. But then other times you use something more complex than Excel. But the long and the short is we're talking about integration, differentiation, all those things. And again, it depends on in which field do you end up. That's that. All right, we have a question here from Solofelo Horekwang. Thank you for your question. When do you think it's the best time for an engineer to do their postgraduate studies? After gaining industry experience or immediately after undergraduate studies? I'm going to jump to you, Albert, because of your resume.
I think that is a question that will never have 100% correct answer. I think it's when you want to do it in your life really depends on your current situation in your life. For me personally, I think it's also very opportunity driven. For postgraduate studies, you need, especially engineering, you need funding because you must probably going to do hardware. And at the end of the day, you need to live and eat. So if there's no funding, but you want to be able to do it, that's a limiter. And usually what a lot of people do is when you go and work, then they save up some money and then they come and do it part-time. You just need to remember when it's part-time is you're going to work the whole day and then you're going to be doing studies or development or something in the evening as well. So for the period of postgrad later in your life, you can almost assume that you're not going to have a very fun and entertaining life, if I can put it like that. I had the privilege to partly towards my PhD at the end, do some part-time writing up, and it was not the most pleasant experience. I think it's also, at the end of the day, you need to know what you want to do your postgraduate field in. Something that I also want to just highlight is just because you did your undergrad in electrical engineering doesn't mean you have to do your master's or your PhD in electrical engineering. You can pivot to another field because your base is still engineering. Yes, it will be more difficult, but you can really pivot to a mechanical or industrial or a computer master's or PhD. That's not the end of the world if you're not sure because I have electrical, I need to stay in electrical. I think personally for me, I would say while you are busy, just go with it if you have the means and the opportunity. If you're not sure and later in life you feel it's something that would provide you internal gratification, because at the end of the day, you need to do a PhD and a master's for the right reason. And doing it to be called a doctor is not the right reason. It's going to be horrifying for that period of your life and you're not going to enjoy it. So for me personally, is if that's something that you really want to have on your CV and gives you that, listen, yeah, this is what I wanted to do and I wanted to be this expert in this field, then do it. So I think for me, and I said it now a couple of times, you really need to know why you want to do postgraduate studies. I think there's a really big misperception in the world currently that I need a master's and a PhD because I'm going to get more money and more exposure and better projects and. That's not true. It just makes you a more specialized people. In some cases, it's actually sometimes a limiting factor because you are too specialized and companies can't afford you. So again, you really need to make sure at that stage of your life, that's what you want and that's what you need.
Thank you very much, Albert. Tolofelo, I hope that answers your question. And again, normally what I tell students is I tell them, just come and study 1 year. And that will just in that, even in 6 months, your perception would drastically change and you would start to think differently with regards to studies. But it's good to dream, it's good, and it's good to start thinking about postgraduate studies, but you'll have to see what the future holds. Right. So saam met ons ook vanmiddag, ons het nie net dosente nie, ons het nie net alumni nie, ons het ook een van ons huidige studente, Hendrik de Kok al die pad van die plaas af daarso in Hoopstad. Hy is 'n derde jaar elektries-elektroniese ingenieurstudent. En ja, Hendrik, wat is jou belewenis as 'n student? Jy's nou al 3 jaar in hierdie program in. Jy's met lockdown ook in. Wat is jou belewenis van hierdie kursus tot dusver?
Goeiemôre Corneels. Ek wil eers net sê dit is nogal dis baie harde werk. Eerste op die dag wat jy daar instap, moet jy besef jy gaan nogal jou prioriteite moet stel. Jy gaan moet besluit wat vir jou belangrik is. Dis nie net hoe kan ek sê 'n studentelewe nie. Jy gaan besluit ek byvoorbeeld ek in my eerste jaar moes ek een keer nee gesê het vir 'n matriekafskeid en 'n paar formele funksies. Maar dis nie waaroor dit gaan nie. Ek moet so ook sê die eerste 2 jaar is baie BSc jare, maar veral wiskunde en fisika. En dan is hier en daar 'n paar elektriese swaarstoom vakke en kleinstroom vakke by. Maar eerste 2 jaar fokus maar op die BSc vakke. En dan hier in jou derde en jou 4 jaar raak dit regtig interessant. Ek het baie belang gestel in hernubare energie toe ek klein was. Ek het ook gehou om goed uitmekaar uit te haal, wat bietjie met stroombaantjies te doen gehad en so aan. Ek het baie geniet en ja. Dis maar dit.
Right. So, just to just elaborate on what you just said, and that's an important thing that you're saying, Andre. First of all, you need to get your priorities right. That's the first thing. Studying engineering is not a holiday, and I think we'd rather be honest than you enroll for something with the idea that it's going to be Aventura and then it's not. So it's hard work. You need to prioritize. Sometimes it means you will have to say no for the fun things in life, for the better things in life. I can put it that way. And then just also a technical point, and that makes sense. And Andre, I will just throw that back to you. So the first 2 years, more BSc kind of, more physics, more mathematics, and then it ventures into the area of more electronic subjects. And what Hendrik said, Andre, that's something that we pick up amongst our students. That sometimes the first 2 years, they have to really work hard to get through the basics to get to the fun part. It's like you first have to eat your vegetables before you can get to the nice part and the pudding in the end. What do you have to say? What's your perception or your experience with regards to students first 2 years and then third year, fourth year, enjoying the curriculum?
Yeah, it's I think the important thing here is to realize that if you have the capability to pass the maths and the science at school level and get the marks that you need to study engineering, you have it in you to finish engineering. But then you need to daily choose to build on that and to really put in the work. Everyone that has the high school marks can pass engineering, but you need to, as is said, you need to make the sacrifices required for that, and that's just it. And you'll there's there's a variety of ways guys do that. So sometimes guys take a little bit longer. That's also fine. But yeah, you'll need to work hard. I was just thinking that maybe it's a question of after your first and second year, you've got acquainted or you've got acclimated to this hard work, sitting, working through stuff. When it's exam time, you're gonna be studying the whole day from 7, 8 in the morning till 10, 11 at night. That's what you're gonna do. That's what's required. You're not gonna be watching some series, and you're not gonna be playing around in a coffee shop. That's you can't do that. So I think maybe it's also a question of once you've passed all of those maths and those science, you've become acquainted to working hard and to really giving your best. It is unfortunately true that engineering is applied science. We are built, engineers are built on the science. That's where it comes from. when Isaac Newton and those guys were busy, there weren't your engineers, your scientists, your mathematicians. It was all just this bundle of things. A lot of the progress made in the engineering world or in the science world was through scientists. So engineering is applied science. You need to have this stuff in your toolbox, just like you can't be expected to work in a country and not speak the language, or be expected to be very good at music but not have a solid base to build that on. Just the same with engineering, and it's the same, I think, in all study fields. There's going to be some basics on which you build, and for us it's math and science. And it also comes from EXA, the Engineering Council, and their requirements to make our degree applicable in the whole world, or accredited. We need those a large portion of the degree to be in the maths and the science, which you do in the first 2 years.
Maybe Corneels, if I can just add on to two comments maybe there. I think firstly with Andre, the engineer's role is to act as the link between what the scientists developed and prove in the lab and make it commercially viable. So if you don't understand their language, you won't be able to make it into a product that can be used or a system that can be worked on by people that only have technical system skills. So your technicians and your artisans. You act as a link. So therefore you need to have that scientific base. And the more you work on it, the more you appreciate it, and the less you start using it at the end of the day. But you will always revert back to the fundamental concepts. So that's one thing that maybe you should see an engineer as the link between the complexity of the lab and the reality of the real world. And then secondly, in terms of your experience as a varsity student, I think there is a big misconception that because you are an engineer, you have no social life and you never are involved in anything other than engineering. My personal experience, I could say that I played university level sports. So yes, it's tough. You have the time, but it means that when the rest of your mates are going maybe for a beer, you need to go to the field or to the gym to train because of your requirement and your commitment on the university sports level. And in a later stage in my university career, I was more, and I call it a career because I was 10 years at the place, so it's a career at the end of the day. And later in my life, I was very much involved in student life activities. So you can be part of the residential culture on campus, which I believe is one of the key things that distinguish Northwest University from your big city universities. You've got the possibility to interact with other students. And I think a lot of engineers miss that you don't get involved with other people on campus. Because the world in which you're going to work isn't just engineers. It is technicians, it's accountants, it's teachers, it's everybody. So you need to learn how those people work and think. And the Northwest University really gives you that opportunity. So don't use the excuse in engineering, but it's so difficult and it takes so much up from my time and. Really, if you want to distinguish yourself and really become a good engineer, you need to interact with the peer, with the reasonable man. And yes, it might mean that you study a bit longer. So be it. You're not going to get paid less at the end of the day. And I think one thing a lot of people need to also realize is there's no distinguishing between a guy that got 95 for his engineering degree and a guy that got 51. And I really learned that fairly quickly, that for me to be able to be involved in student life, I celebrated when I got a 50, 55, because I knew I was doing it right. If I got a 90, then I knew I was doing it wrong. So you really need to remember, there's no one going to say at the end of the day, hey, here's Albert, and he got a 90 aggregate for his engineering degree. Yes, it's you've got to distinct you passed your degree with cum laude, and in 10 years' time, you can't even remember you did it with cum laude. So really, you need to remember that engineering is life, and you need to integrate into campus life. That's just maybe my 2 cents, which I think sometimes gets thrown over the stigma that we are really hardcore, hard-working engineers. I can say with all honesty, I worked hard, but I wasn't the most academically top performer because I realized there was no need for me to be the academical top performer. But I learned a lot more other skills on campus in social life, which all of my peers didn't develop and didn't get exposed to.
Right.
Yeah,
Yeah.
no, I think you're right, and I think maybe we must also say that there's place for both. There's a spectrum. What I always what's always nice to me about university and the Northwest University specifically is there's place for that. So if you're a person that does music on a specific on a high level, there's an orchestra, a university orchestra that you can be part of. If you are a voortrekker on a specific level, there's going to be a group of people that's going to be part and support that. So university is a place where you can find people that resonates with what you want to do, and that is I think the takeaway here is that you can develop as a person, be it as a very very hard studying person, being as a hard partying person. I think there's a space for them all, and all of these people can be very good engineers.
Wonderful. Andre, question. Frank Corneel vra, wat kan 'n mens doen om meer voorbereid te wees as 'n mens hierdie wil studeer? Ek neem aan Franco is nog op skool, of dis Franco se pa, of dis iemand wat namens Franco 'n vraag vra. But the question is, what can you do to be more prepared for this field if you want to study it? Baie dankie vir die vraag.
I think you can, if you're not exactly certain what engineering you want to study, then I think to prepare would be to shadow someone somewhere doing the work you think you want to do. So there's a lot of misperception on a lot of industries and a lot of fields. So you would think mining is always dirty, and telecommunication is always high tech, and it's not necessarily like that. So I think that's one thing, to dig a little bit into what you think you want to study, and then also, as Albert said, and a lot of guys come from school without a lot of programming experience. I was lucky enough that I had a very good programming background from school, but it's something that there's so many resources available, free resources on the internet. Just pick one and just do it. If it's Python, it doesn't really matter the language. Just get a basis on how do I get a computer to do things for me. And it's even more of just not being scared of programming, than being fluent in Excel, in whatever. It can be in Excel. You can do a lot of amazing things, but just getting over that barrier of it's programming. I can't program. I'm scared of programming. So that might be one thing that for your first few years, there's a lot of guys that if they didn't have programming in school, they struggle a lot with that thing. And as Albert said, programming is around us. It's a big part of our world. Except for those two, I can't really now think of anything else. I think shadow someone and get some basis in programming.
Ek dink daar's 'n baie goeie antwoord en baie goeie raad. As dit kan, en ek beveel dit altyd ten sterkste toe. Kyk of jy iemand in die industrie kan shadow. Kry Albert se kontakbesonderhede en vlieg oor Oostenryk toe as die grense weer oop is. En dan gaan kyk jy hoe lyk dit in Oostenryk. Maar die feit van die saak is, maak seker en ek kan daarvan getuig, hoe meer mense sien hoe lyk die beroep eendag, hoe meer gaan dit jou motiveer as jy sukkel om daai partiële diferensiaalvergelykings op te los om deur te druk en harder te swat, want jy kan die einddoel kan jy visualiseer. So ek sal stem 100% saam daarmee. En dan ook 'n ding, en Albert het dit ook vroeër gesê, daar is myns insiens, en ek stem saam met wat hulle sê, nie een ingenieursveld waarin daar nie 'n mate van programmering gaan wees. So om 'n mate van programmering reeds jouself aan bloot te stel vroeër, sal nie skade doen nie, inteendeel jy kan net daarby baat. Maar aan die ander kant, ek sal 'n derde ding bygooi. En my derde stuk sal wees, wees teenwoordig waar jy nou is. I think we sometimes get so ahead of ourselves that we forget to live. Also be present where you are now. Embrace where you are now. Don't live tomorrow and the day after tomorrow. And I think we waste our lives just worrying about tomorrow and the day after tomorrow without just being present and enjoying the day that we have today as a gift, the present, you know. So, geniet net vandag. Ek sal dit ook net sê, wees net teenwoordig, geniet dit. Jy het die wonderlike voorreg van lewe vandag, so lewe vandag. Doen nou twee goeders, maar dan ook bygesê, if you don't shadow somebody and if you don't do the programming, you will still be all right. If you pass your maths and you pass your physical science, you will manage. Don't worry. You will manage. Many have done it before you without doing all these things, and they've completed their degrees in 4 years' time. You'll also be able to do that if you work hard and you prioritize. Right. Hendrik, ek het 'n vraag vir jou ook. Ekskuus, Andre gaan, sê maar.
No, maybe we can talk about that, but I think you should also be proud of where you're coming from, and I want to so if you're coming from a town, a large town, a rural area, you've got some experience, some exposure. Living on a farm or living in a town, that really doesn't exclude you from coming up with good solutions to the problems we face in the world. So I think that's also something that you shouldn't be worried about. I know about a lot of guys that come from small places, which really go far and really do a lot of great things.
Andre, while you're talking, a question came through, and Andre, I'll ask you this question a bit later, but question for you, Andre, is from Tapiwanashe Kudomu, who asked, good day, if I study mechanical engineering for first, am I able to change to electrical and electronic engineering in my second year? So daai vraag is 'n redelike belangrike vraag, en ek dink dit is 'n vraag wat deur die bank gevra kan word en is toepaslik op al 8 ons programme. As ek begin met 'n sekere program, hoe maklik is dit om oor te skakel na 'n ander program binne ingenieurswese? How easy is it to change from one program in engineering to another program in engineering? I'm asking you. Yes.
If I remember correctly, for mechanical to electrical, if you do it after the first semester, you'll still be there's still a lot of subjects that's the same, but usually it'll mean there's a subject or two that you need to do additionally. Usually you'll add a year to your studies, but I'm not exactly sure. I'm relatively sure if you finish your first degree mechanical, first year of mechanical engineering, you'll be able to enroll in as a second year electrical student for most of your subjects, but not all of them. I think there is a little bit of a difference. There's 2 or 3 subjects is different. So it might cost you some time.
Yes.
That's the reality.
I think a couple of years ago, there were fewer programs and they were overlapping quite a lot. So there was a time, many moons ago, where you could have started with one chemical and jump over to electrical, and it wouldn't have been even a problem. You would have just continued as is. But the 8 programs, well, some of them are closer, some of them are further apart, but it's not as it used to be. And at this point in time, as Professor Grobler said, it might cost you an additional year or an additional semester, but you'll have to look at that. So with that being said, I mean, we still have 6 months to go before the end of the year, before the start of the new academic year. Use the following 6 months wisely. And there is, I know you need to prepare most probably for a final exam at the end of matric, but if at all possible, between finishing your matric and starting your career as a student, I would recommend try to find a place where you can shadow perhaps a mechanical engineer and an electronic engineer. And perhaps you can even go to a place like Eskom, or you can go to a place like Sasol, if at all possible. And within the same company, you will find both engineers. And you can do one day with one engineer and shadow the other engineer the other day. I think that's a brilliant suggestion, and that can help you to at least make a more informed decision. And that's perhaps one thing. And I'm going to ask to Albert, I'm going to ask this. We have this idea of engineering, and it's lovely. But there's also, with any other job, a lot of admin that needs to be done. So I'm just shooting from the hip now. How many hours a day, Albert, do you spend in meetings, for instance? How often do you find yourself in meetings?
Yes, I would say almost half my day is in meetings. Actively participating in all the meetings is not always required, but sometimes a physical presence is all needed. That's also not a strange phenomenon to see an engineer who's sitting in a meeting who's not partaking but still working. So yes, you will be doing admin. You will need to keep track of your hours if you are working on multiple projects. So working an hour on this project and 2 hours on that, you need to make sure that you log your hours accordingly. Project planning, if there's certain things that you need to plan ahead for, it's, I would say, at least half of your time, even in both industries that I worked with, is loaded with meetings. It's not always the best thing, but it is needed, especially in areas where there is multidisciplinary components. And therefore, you really need to be able to understand the role of the meeting and the goal of the meeting and the objective. So it's really, it's the, let's say, the less glamour side of engineering is project management, and financial management is also a big part. So more than half of your time in the corporate world will be spent on administrative tasks. You might be, if you're a bit more lazy, you can push it down to a third of your time, but you're not going to get away from it, unfortunately.
Thank you very much, Albert. And I asked that question with, there's a reason for asking that question, because that's why it's so important to also shadow somebody in industry. Because we can go through the yearbook, we can discuss each and every single subject that you will be taking as an undergraduate student, and you will get very excited. But then, to be realistic, you will spend a great deal of your time, for instance, in some things like meetings. And that is a myth-busting statement, because many times people say, yeah, but I don't want to become an engineer. I want to work with people. Well, you're going to spend a lot of time working with people on higher managerial levels. You're going to talk to people who are on lower managerial levels. You're going to talk to ordinary laborers, and you will have to communicate with those people, build relationships with those people, and earn their trust. So the long and the short is, yes, there are things like meetings. There are things like building relationships with various stakeholders, and you need to be good at that. Right. Heinrich,
Sorry,
ek gaan, okay, go for it, Albert.
One last thing, sorry for interrupting you. I think it's also your role as engineer, or let's say your ultimate goal. You can be a manager. So my boss sits in front of me, and he's the whole day in meetings. Whether it's over Skype or Zoom or whatever you want to use it, he purely does administrative roles. So I think it's the likelihood of what you are going to be doing is really defined by your goal as what you want to become in life. There's this good combination that everybody always talks about: engineer with an MBA. If you have an engineering degree and an MBA, you're not going to do technical stuff anymore. Then you had to make that decision in advance that you want to be in a managerial role. Then you get guys, that's more my suit, that I want to become a technical expert. So I don't want to manage a group of people. So I want to manage a technical project. I will still manage people, only to a lesser extent, with a different degree at the end of the day.
Thank you very much. We're going to go to our concluding remarks. If there are any other questions, I will catch it in the corner of my eye. I'll see that. Sal ek sien as daar enige vrae nog is. Maar Heinrich, ek gaan by jou begin. Ek gaan vir jou vra, hoekom sal jy sê is elektroniese ingenieurs gesê, why would you say is that the degree somebody should pursue? En dan gaan ek dit vir jou vra Andrei en dan sal ek net laas net 'n of 'n twee sinnertjie net om hom saam te vat. Kom ons hoor wat jy te sê het, Hanrich.
Okay, so dankie professor. Hoekom elektriese en elektroniese ingenieurs? Daar's is ongelooflik baie geleenthede daar buite vir die rigting. Dit gaan van klein dorpies tot groot stede tot dit gaan oor die industrie of waar jy gebly
Ons het Hanrich verloor. Hanrich, as hy weer terugkom, gaan ons weer met hom gesels. But that's life, eh? That's the post-COVID-19 world we live in, where you are there and then you're not there anymore. So, Andrei, wat sou jou slogan wees? Wat jy sê?
Wel, ek dink elektriese ingenieurs maak die wêreld in die rondte draai. Dis maar net soos dit is. Without electricity, we're back in the dark ages. Yeah, we're part of what makes modern society what it is.
Wonderful. Albert, last words from your side?
I think for me, the main reason why electronic engineering currently now, I would say we are in the golden age of electrical and electronical engineering. If we look at all the developments currently going on in the world, they are all set around some form of energy or renewable energy or conversion of energy. So if you want to be in this era where we are really getting the shine and the possibility, electronical engineering is for you. You are going to work on the nice stuff. You're going to be involved in the next era of things. So that's though I would say it's our time. The electrical engineers, we've always been there and we really didn't get the shine. But for me, if you want to be relevant in making sure that you've got influence in the next generation, what they will be doing and gaining, then I would say electronic engineering is for you.
Thank you very much, Albert. Hanrich, we're going to give you another chance. We lost you. Let's try take two. Hanrich, all the way from Hoopstad.
Yes, reg baie dankie. Ek weet nou nie wat daar gebeur het nie, maar soos ek gesê het, dit is oral rondom ons en soos Albert ook sê, dit is ons tyd om te shine. Dit is net amazing hoe om met sulke groot hoeveelheid stroom te kan werk en hoe om te leer waar dit eintlik vandaan kom en die wiskunde daar agter en die science daar agter en hoe jy in die eerste en tweede jaar leer hoe alles gebaseer is op hierdie wiskundes en hierdie science eintlik in jou derde en vierde jaar kom alles bymekaar is. Hoekom dit in 'n kragstelsel ingaan, hoekom dit in die wêreld daar buite aangaan. Dit is net amazing daai hoe alles beweeg nou alles saamkom. Ja.
Baie dankie, Hanrich. Baie dankie. So with that, we've reached the end of this afternoon session. I hope that you have a better understanding of electronic engineering. Ek hoop jy verstaan dit 'n bietjie beter. Môre gaan ons aan en môre gaan ons gesels oor rekenaar elektroniese ingenieurswese. Totaal ander paneel, totaal ander groep mense wat by ons aansluit en dan gaan ons spesifiek kyk na daai. So in die verlede het ons daai twee saam hanteer, nou doen ons dit apart. So die van julle wat sê, ek wonder, should I be doing this one or this one? Please tune in tomorrow again at 3 o'clock. And thank you to Franco and Solofelo and Tapiwanashe for asking those questions. Hou aan vra, ons wil graag daai vrae vir julle beantwoord, ons wil julle kan help. Hanrich, baie dankie, jy wat daarso ingeskakel het, al die pad uit Hoopstad, Professor Andre Grobler, al die pad uit Potchefstroom, and then of course Albert Sorgdrager, Dr. Albert Sorgdrager, all the way from Linz in Austria. Thank you very much. Danke schön für deine Zeit und viel Erfolg mit der deutschen Sprache. Es ist nicht immer so leicht. I hope it goes well with the German. and with the Grüß Gott and all those nice things that they say over there. But yes, ons sien mekaar môre. We see each other tomorrow morning, or tomorrow afternoon rather, at 3 o'clock. Mag julle 'n wonderlike aand hê. Have a blessed evening. Salali gasle, usale senkle.